Okay, this is a second example in Calculus Part 8, and let's just start in with the question. They say there's this open tank. It's an open tank, so it doesn't have anything in the top here. It must have a square base and sides that are perpendicular to the base, a box without a lid. Okay, the tank must have a capacity of 8 cubic meters. That's the volume. Determine the dimensions of the tank so that a minimum amount of metal is used. Okay, so what you've got is two different problems here. The first one is you need to think about the equation for the volume of this thing here. Well, that's pretty easy. It's just x times x is x squared times how tall it is. So it's x squared times h, and that has to equal 8. So we've got an equation for the volume. Then we need an equation for the surface area. Well, there's x squared, and then there's 4x times h and 4 sides around the top. The sixth side is open, so we've just got the 4xh's plus the x squared, and that's the area. We need both of those equations, so here's the equation for the area, x squared plus the 4 sides that are x times h. We've got the volume, which is x times h. Well, all these questions, you have to take that one thing you don't know, which is h, and use the volume equation to get it in terms of x squared. So all we do is we divide by x squared, we get h equals 8 over x squared. Now, just like we did in the first example, we substitute. Instead of h, we put in h over x squared. Well, it looks like we're going to get it. We've got x squared plus 4x times 8 over x squared. That's x squared. 4 times 8 is 32. X over x squared is just 1 over x. Well, there's your formula. That's the main step right there. You've got an equation for the area of this box. X squared plus 32 over x. Well, we want to minimize the area. Whenever minimize or maximize, whatever kind of shape this is, we're looking for a local minimum. Then back here it said that we want to minimize. What we have to do is take the derivative and let it equal 0. Every time we do that, we take the derivative of this x squared plus 32 over x. See, like we put it in the right form, no x to the minus 1. We take the derivative, which is 2x, minus 32, x to the minus 2, and we let it equal 0. So it looks a little bit strange here. We've got 2x minus 32 over x squared equals 0, but we multiply by the denominator, we get 2x cubed equals minus 32 equals 0. We add 32, we divide by 2, and then the last step, we've got x cubed is 16. Just take the cube root of both sides, we get that x equals 2, 5, 2. Okay, so x equals 2, 5, 2. That's the area of the base, 2.52 times 2.52, and we can just put it back into the original formula to get what the height is. That original formula back here for h, 8 divided by that 2.52 squared, we get 1.26. That's the minimum surface area, and that's the answer. Hopefully that made some sort of sense. I'm just going to go over it again. You know, you've got to build two equations, and then with one of the equations, you have to put it just in terms of x. So the volume one, you make h equals 8 over x squared, and then you substitute it into your area formula. And once you've done that, you've got an equation just in x. You find the derivative in terms of x. You let it equal 0, and you solve, and there's all your answers. Hopefully this video helped. I hope it helped. Okay.